So as for this panel, what's neat is one of the things besides getting in the those PCBs, I also got in some red LEDs, and so this panel, it's wired up for block occupancy. So the switches will work here to call up the the routes, but ideally what the red lights are showing is which blocks are occupied. So at a glance, you're going to see which which blocks are occupied, as opposed to that one, which is there. That one's lighting up to tell you what route is selected. Again, ideally, would my best goal would be is if like my original plan was to have a bicolor LEDs. So green if it's selected, red if it's occupied, and off if it's not occupied or not selected. So, but in the meantime, this is a panel for that, like I said, is for block detection. So underneath, the way I got this guy wired up is so this is a Team Digital board here. It's a SIC24. So it's 8 inputs and 24 outputs. I need 32, so I'm a little bit short on this one. And this is one of my homemade loconet boards. So that ended up costing me maybe about $10 to build. Again, these boards, they're 50 millimeters by 100. So if you with the JLC PCB, if you ordered boards like this, you can get 10 boards for $5. And if you double them up, put 2 on a board, if you're able to fit 2 on the in the 100 by 100, you'll end up having 20 boards. So that becomes really dirt cheap. And but what happens is these boards are made. There's no smarts to them. They're only made as input boards, inputs. So what happens is I wire it up to the switches, like you'll see here. The wires are jumped to the. I'll turn it this way around. See the headers here. So it starts to get a little bit messy now because you're starting to have these wires as opposed to everything, like I said, on that board where everything is like hidden. Or the other boards that have all the connectors, like these the ribbon cables, like you see hidden back here. These ones I'm just using these jumper wires, these DuPont connectors. So there's going to be a bunch of them wiring up to this. But what's neat about this, like I said, the homemade one is there's 32 inputs. So and then this is just a ways to daisy chain the loconet cables. So the lights, the switches actually on because there's lights and switches on this board. So the switches get wired up to the inputs here, and that creates a. You give that board an address, and then the next 32 consecutive addresses are the input. So depending on the input, let's say you give it an address of 400. So then it's 400 to 432 are the inputs. So now what happens is when you press the button if you have a loconet monitor, you're going to see 400 is going to show up as sensor 400 went high, and then you release the button, 400 went low, and so forth. So as you jump through all of them, it'll just give you that information. So now you need to be able to take that information and then say, okay, well, if let's say the first switch was for 400, you have to be able to say, okay, A is for this route is 400. Well, now what? Flip a route. So you have to make that association between the sensor address and the and what you want to happen. Whereas in those boards, the other boards, everything is like the boards have the smarts. You program them. That homemade board doesn't. So you have to offload that information to another board. And in my case, I'm offloading it to the CSCe boards, which has a little bit room left over. And those CSCe boards, they maneuver for the LEDs, these signal masks. So you know how it is when they, depending on the turnout, the block occupancy, then the lights turn. So there's 66 on the CSCe board, 66 inputs configurations. So I have 3 of those boards operating all my my signals. So if I have spare, then in that spare memory I could say go back to here and say, okay, if you know 400, if sensor 400 is triggered, then run route, you know, 400, whatever it is, whatever I gave that route, you know, the address for the for that turnout, and so forth, and just cascade through them. So that's how that's working for now. So I'll give an update a little later on. Bye bye.